Alright, we're solving some more complicated expressions here. You can see in this expression we have, or the equations rather, in this equation we have x's in multiple locations. So we would not be able to start with the whole unwrapping the package metaphor that I've been using. We would really need to start by simplifying. And to simplify this, you can see if I rewrite everything as addition, I'm going to need to use the distributive property. And specifically, I need to distribute this negative through the parentheses. So I'm going to get 5x plus a negative 2x plus 3 equals 27. So I changed the 2x to a negative 2x. I changed the negative 3 to a positive 3 because I'm distributing the negative through the parentheses. At this point, I can combine like terms. The 5x and the negative 2x can combine to give me 3x. So I end up with 3x plus 3 equals 27. Now I've simplified as far as I can go. Now I can go ahead and use the unwrapping the package metaphor, analogy, I guess. Yeah, it's an analogy. I can use the unwrapping the package analogy to work on this one. So the x is multiplied by the 3, then I add 3. To undo these, I will start by subtracting 3 from both sides, giving me 3x equals 24. Divide both sides by 3, giving me x equals 8. And these, I keep saying it, whenever we get more complicated equations, it becomes more and more necessary to check your work. So checking your work, again, is just a matter of plugging in your solution and checking to make sure that it actually satisfies the equation. So we get, this is 5x minus parentheses, then we have 2 times x minus 3 equals 27. So 2 times x, that's 2 times 8 in this case, that's 16. 40 minus parentheses 16 minus 3 equals 27. We're checking to see if this is true. So 40 minus 13 equals question mark 27. That is a true statement. So I verified that this x equals 8 is the solution. Oops. That is the solution I was looking for. Alright, let me erase that. There. Okay. On this one, I'm going to need to use the distributive property. To make sure I distribute everything properly, I'm doing the same thing I did before, changing all my my subtractions to addition, so that I can see that the number I need to distribute through the parentheses is a negative 3, not a positive 3. We get 8 plus, let's see, this is a negative 6, I guess. Negative 3 times 2 is negative 6. Negative 3 times negative 3x is a positive 9x. So we get 8 plus negative 6 plus 9x equals 34. The 8 and the 34 are the same. The only things that really changed is this parentheses. I can combine like terms. The 8 and the negative 6 are both constants. I can combine them. 8 minus 6 is 2. Alright, so now I've simplified as far as I can go. Now I can unwrap my x. And I'll start by subtracting 2 from both sides because this, it's multiplied by the 9. Then I add the 2, so I'll undo the 2 first. I get 9x equals 32. Divide both sides by 9. This one's not going to come out nicely, but it's not such a big deal. 32 ninths. There are not any common factors between 32 and 9. I can tell that because 9, which is 3 times 3, the only factors that would be able to cancel out from 9 are 3's. 3 is not a factor of 32. 30 is a multiple of 3. 33 is a multiple of 30. Whatever. 33 is a multiple of 3 as well. And so it kind of skips over the 32. That's how I can tell that it's not the 3 is not a factor here. That would be my final answer. This one might be a little bit trickier to check, so what I'm going to do is I'm going to pull out my calculator. And let's see what 32 ninths looks like. Okay, it's 3.5 repeating. So what I'm going to do is I'm going to just evaluate the left-hand side of this equation. I'm going to say 8 minus parentheses 3 minus, 2. Let me start over. 8 minus 3 parentheses 2 minus 3x, except instead of x I'll write 3.5. Oops. Should do a times in there, or put this in parentheses, better yet. 3.5. I'll just do a few 5s on there. I am rounding it, but oh well. It'll let me know if I'm close. Close the parentheses for my variable, close the parentheses for the parentheses, and that's the entire side of that equation. This should give me 34, or something close to it, and it does give me 34. Well, something close to it, 39.9s, and then a 5. That's far enough to the right there that I can attribute that to the rounding error I made from my from this by stopping writing the 5s. So I'll call that 34, which means that I'm convinced that this is the correct answer. That is the solution to that equation. Alright, in this example, I need to distribute the 4 through these parentheses. That doesn't necessarily have to be the way I'm going to go about it, but that is the general recommendation that I made to you. If you can simplify, you start by simplifying. So we get 4x minus 8 equals 26. I'll add 8 to both sides to get rid of that 8. Gives me 4x equals 34. Divide both sides by 4. This gives me x equals 34 divided by 4. Looks like there's a common factor of 2 that I can cancel, giving me 17 over 2. I might call that one 17 over 2 is what, 8.5? I might call that 8.5, especially if I'm plugging it into the calculator to check my work here. 4 parentheses 8.5 minus 2. Close the parentheses. This should give me 26, and it does. Alright, on this one, I want to distribute my negative 2 through the parentheses, giving me 11 equals negative 2y plus negative 10. I want to, this is when I'm unwrapping my y here, I'm multiplying by negative 2, then adding negative 10. Let me call that subtracting 10 because it's easier to think about. So to undo subtracting 10, I will add 10 to both sides, giving me 21 equals negative 2y. Divide both sides by negative 2. I get negative 21 halves equals y. If I want to call that negative 10.5, that works, because 21 divided by 2 is 10.5. So my solution here would be negative 10.5, and I could check this by plugging it back into the original equation. Negative 2 times negative 10.5 plus 5, close up my parentheses, and it gives me the 11 that I expected.